and professor with effect from 1/1/2009. Out of 30 years of service career, he served as a teacher, researcher, guide to PG student, administrator. As a member of course committee of about 20 years, he has contributed significantly to restructure and modify the course content of almost all the courses in the discipline of agronomy. He has guided 13 MSc and 8 PhD scholars as major advisor and more than 5 dozen students as member advisory committee. He has more than 80 research papers to his credit published in international and national journals. He has also contributed about 4 dozen technical articles in various magazines and newspapers as an effort to disseminate latest know-how. He delivered more than 200 talks at through and radio. Besides being a member of scientific, professional, and technical committees, his remarkable contribution to agricultural education is founding, establishing 2 new colleges, namely College of Agriculture at Lalsor and SKN College of Agribusiness Management, Jobner. He served as Chief Agronomist of All India Coordinated Research Project on Integrated Farming System and Head of Department of the Division of Agronomy at Rajasthan Agricultural Research Institute, Durgapura, Jaipur. He also performed additional duties of Controller of Examination at SKN Agricultural University for 3.5 years. He has established Agri-Business Incubator at SKN Agricultural University, Jobner, with the support from DAC, uh, MO, Agricultural and Farmers Association, Government of India for mentoring, nurturing, and honing the skills of innovators. He has also taken over as the Director of Research of SKN Agricultural University, Jobner, with effect from 1st August 2019. This is welcome, sir. For first, let me express my heartiest thanks that you accepted to become esteemed speaker for this work, this faculty development program. Uh, Welcome, sir.
Thank you, Singh Saab. Good morning, everyone. Honorable chairs, Dr. Parikshit Singh, learned faculty from IIT Kota and other learned teachers, and all the participants. It's my pride privilege to be a speaker on the topic recent trends in IoT-based smart farming. You have just heard Dr. O.P. Yadav, very eminent scientist, administrator, who spoke on possibilities and challenges of IoT in agriculture. So let's first consider why agriculture has become so important, particularly after COVID-19 pandemic era. So with the help of certain slides, let's consider the role of agriculture. Agriculture is the backbone of Indian economy. It provides us food, feed, fodder, fiber, fuel, medicine, dye, eggs, meat, hide, milk, shelter, fish, and so many products come from agriculture. It's a source of employment to more than 55% of Indian population. It provides food security. Before the Green Revolution, we depended heavily on the imported food, particularly wheat and maize. Now we have not only become self-sufficient with regard to food grain production, but we are exporting food grain to nearby countries. And agriculture secures, it provides nutritional security. It contributes to almost 15% to our gross domestic product, and it provides raw material to so many agro-based industries like textile, like sugar mills, like dye and atta mill, dal mill, maida, soybean meal. And it contributes to more than 10% to our export potential. Then in world scenario, every sixth person is an Indian, and so is the situation with livestock population. We have only 4% of the world water resources, and our geographical area accounts for only 2.4% of the total world area. Then out of the 329 million hectare, we are cultivating net 142 million hectare, and out of that 43% is net irrigated area, and the rest remains unirrigated or rain fed because we don't have plenty of sweet irrigation water. Our cropping intensity is 140%, means we are able to cultivate just 40% of our area twice a year. Then more than 50% of our population depends directly or indirectly for its livelihood in agriculture. Then if we look at the crop production estimates, this year, despite of the COVID, our country produced record food grain, and it was of the order of 292 million tons, including that of rice, wheat, pulses, and nutri-cereals. These are the core cereals like bajra in Rajasthan and some other grains in different states. Then oilseed production is of the order of 34 million ton, cotton and sugarcane. Then the country has witnessed radical changes in agricultural scenario. In the year 1951-52, when the first 5-year plan commenced, India produced just 51 million tons of food grains, which has now exceeded 291 million tons. This is a miraculous achievement. Similarly, with regard to horticultural crops like fruits and vegetables, the achievement has been more than 10 times, and now we are producing horticulture produce more than the food grains. Now it's 320 million ton. Similarly, with regard to milk production, we top in the list of milk producing countries in world, and it is 184 million ton. The yellow revolution means production of oil seeds. It's around 35 million ton, but still India is largest producer and consumer of oil seeds, oil, and we are importing almost 50% of our total demand from different countries. And with regard to egg production, it is 88 billion numbers. Fish production exceeded 12 million ton. So we have become self-sufficient, not only self-sufficient, but exporter of more the food commodities. But the pity is that the income of farmer is less. Cost is high. Mounting pressure on our resources and malnutrition still persists in a large sector of population. Ever increasing demand for food, fodder, feed, and ever increasing pressure on natural resources and our environmental issues like per capita availability of land is declining, our forests have been cleared, our soil health has dwindled, per capita availability of water has declined, our atmosphere is polluted, new pests have erupted because of the climate change. So cost of production has increased and profit has decreased. Our farmers are dissatisfied. They are looking for alternative job opportunities if possible, and they are ready to abandon the farming. Most of them are ready to abandon the farming business. Let me also inform our diverse group of listeners, participants, that almost 85% of the farming community are small or marginal farmers, means having less than 2 hectare of land size. So different aspects are being promoted by the government of India or by the state government to improve the income of farmers and provide nutritional security. For example, organic farming, for example, integrated farming system in which we offer a basket of options to the farmers. For example, goat rearing or fish rearing or horticultural products or the vegetable growing, crop production remains at the core. So out of them, a farmer can choose one, two, or three, or four, more than three different activities to improve his income. Then crop diversification is another aspect by which one can improve his income. Conservation agriculture to conserve our natural resources, our energy. Nanotechnology is a recent aspect. Then allelopathy in agriculture. Then integrated crop management means we can monitor the crops and we can apply the fertilizers. And here is the use of artificial intelligence or the IoT. Then sustainable agriculture practices to be followed to improve the income of farmers. Vertical farming is another aspect by which one can improve the income and add the less farm area. Then there are biotic and abiotic stresses imposed by the insect, pest, and abiotic stresses are imposed by the physical factors like temperature or less rainfall or the radiation. Then climate resilient agriculture means how we can tame our climate, how we can avert the vagaries of weather. Contract farming is another aspect by which farmers can be secure, they can bear minimum risk, and they can assure of their income. Then genetic engineering is the another aspect to reduce the pest population or to save our crops. Then protected cultivation in greenhouses or shed nets or glass houses to improve the income from reduced area. Then crop modeling is another aspect where principles of modeling is followed. Precision farming means use as little as possible and as much as required. Then plant genomics by altering the genetic makeup of the plant. Water resources are dwindling, so how best we can use our water resources.
Sir, it is a request. Can you go for little bit slow so that we can understand? See, we are not from the agriculture background, so if you go little bit slow now, so we can acquire your knowledge, what you're supplied over it.
Sure, sir. Sure. So water resources, our water resources are limited, and rainfall is the ultimate source of water over Indian subcontinent, and rainfall is received in a particular season which we call rainy season. It's different from the Mediterranean climate where the rainfall distribution is throughout the year. So we have to manage with the water we receive during the rainy season, which is confined to just 28 rainy days in a state like Rajasthan. And the ridiculous situation is that India has the place where highest rainfall is received in the world. That's Mawsin Ram, or previously it was Cherrapunji in Meghalaya. And we have the driest place in the world in Thar Desert where we receive less water. So with that limited amount of water, we have to manage. So here comes the role of our scientific tools and knowledge: when to irrigate, how to irrigate, how much to irrigate, and what alternative options are available to use the water very judiciously. So this is integrated water resource management. Then reduce greenhouse gases means agriculture is sometimes blamed to emit methane and other gases. Production of fertilizers, production of pesticides is also blamed to emit lot of smoke and pollute our environment. So how we can reduce the uh, greenhouse gases? Then let's come to our real topic. What's Internet of Things? Why Internet of Things in agriculture? What are the applications? What would be the sensors and implemented methods, advantages and disadvantages of using IoT? So when we talk about IoT, IoT is short form of Internet of Things. The IoT is internetworking of physical devices. The system has ability to transfer data over a network without requiring human to human or human to computer interaction. You are quite familiar. Then there were different stages of internet revolution in the year from the year 1969 to 1995. We call it Internet of Boffins, then Internet of Geeks up to 2000. From the year 2000 to 2007, it was Internet of Masses, then mobile internet, and now IoT from the year 2012 onwards. Then here today, more connected devices than the number of people. Now the world population is estimated to be 7.6 billion, whereas the total connected devices are of the order of 50 billion. Means connected devices now is of the order of 7 per person. Then why Internet of Things? Because it has many applications in agriculture, in smart cities, smart home, healthcare, business sector, traffic monitoring, transport and logistics. This is growing mega trend that will influence everything from business to our daily personal life. Mainly agriculture, as it plays a vital role in development of our country's economy, because agriculture remains the backbone of our Indian economy. Then IoT save fertilizer and chemical, crop protection against different pests. It boosts soil fertility due to small corrections. Means when to apply a fertilizer, how to apply a fertilizer, and how much to apply a fertilizer. At the moment, we are using plant nutrients, particularly the major nutrients, nitrogen, phosphorus, and potassium, of the order of 26 million tons. But plant nutritionists say that it is just 50% of our total requirement. Means we will have to use more plant nutrients to meet the deficiency of these elements in the soil. We are excavating lot of plant nutrients from the soil every year, but we are replacing only a part of it. So more and more plant nutrients will be required to produce our to meet our ever increasing demand of food and other crops. Then IoT controls crop state and prevailing its losses. Then it increases machinery efficiency. It monitors location of farm animals, and it helps tracking processing line equipment conditions. An expected growth of population to 8 billion by the year 2025. IoT technique and the IoT devices will be in great demand. Then effect of climate change will have great impact on agriculture according to IPCC, and IoT based methods shall provide irrigation techniques, and they will help in deciding the right quantity of water at right time. Crop requires moisture, wetness. The rhizosphere has to be wet right from the day of sowing or before sowing to the day of maturity. But it is we to decide how to apply, how much to apply. Our pressurized irrigation system like use of sprinklers or micro sprinklers or our drip irrigation system has to be monitored in such a way that the capacity remains maintained. And if we uh, over irrigate, then it is simply wastage of water. Rather, it will dissolve the soluble plant nutrients on the soil, and it will pollute our groundwater resources, or it will mix with the runoff water, and it will pollute our perennial water bodies. Then various studies have indicated that impoverization of agriculture by modern techniques over past century. So for that, IoT gives a solution. Then automation has been main driver in meeting the rising demand in agriculture. Then what are the things to be considered on IoT? The major objective, how to then from the specific remotely, like irrigation system, one can monitor it from a distant place. Then it will monitor the data collection and it will help in making decisions. Then monitoring and operation part. There are different subheads under monitoring, that basic cameras for monitoring the field as well as livestock, then intelligent cameras, then irrigation, remotely operated irrigation system, small irrigation controllers like sensors, forecast, soil moisture, leaf wetness, for example, use of infrared thermometer. It can take the temperature of the leaf, and with that data, we can go for irrigation, whether to irrigate or not to irrigate. Such decisions can be made. Then automation means techniques of sowing seeds and harvesting technique. Then what is meant by IoT based smart farm? Smart farming is emerging concept that refers to managing farm using modern information and communication technology to increase the quantity as well as quality of produce. Means the quality is also important. At the time of green revolution, only quantity was important just to feed the growing population, but now we are quite concerned about the nutritional security also. So among these technology, the sensors, softwares, connectivity tools, location, robotics, data analysis, everything has become increasingly important in present context. So smart farming will include different sectors like sensing technology, then software applications, communication systems, telematics, hardware and software systems, and data analytic solutions. So the IoT-based smart farming cycle starts with observation, means sensor record observational data from crops, from livestock, from soil or atmosphere. Then the diagnostic part, sensor values are fed to cloud-hosted IoT platform with predefined decision rules and models, also called business logic, that ascertain the condition of examined object and identify any deficiency or need of the crop. For example, if crop is suffering from some fungal disease like mildew, we have some apps and devices that can sense and send the data. When its photograph is uploaded, it sends the data to cloud, and within few minutes, the user will obtain information about the possible diagnostic information and possible solutions. So it helps in decision making and guide about the action to be taken. Then precision farming, because we are wasting our resources, like water or nutrients or our soil resources, flora, fauna. So precision agriculture or the site specific farming is one aspect where we can make increasing use of our IoT. Precision agriculture, it makes farming practices more precise and controlled by realizing smart farming application. Precision agriculture is most famous application of IoT in agriculture. It makes the farming practice more precise and using applications such as livestock monitoring, vehicle training, field observation, and inventory monitoring. The aim of precision farming is to analyze the data generated through sensors or react or decide the action accordingly. It helps farmers to generate data with the help of sensors and analyze that information to take intelligent and very quick decision and timely application. For example, a smart greenhouse is one application. Our greenhouses are there, but when they are not having the IoT facilities, they are just considered as the place of protected cultivation. But when they have the IoT facilities, they enable the weather-based data and means what is the weather outside, how to run the foggers, emitters, or how the temperature inside the greenhouse to be controlled and maintained at a particular level. These sensors collect and transmit the real-time data that help in monitoring the greenhouse state very precisely. And with the help of sensors, the water consumption can be monitored and reduced. Crop weather management is another aspect. Usually the farmer pumps the water more or less to cultivate the land, and that may result in wastage of water, or sometimes the crop may suffer from the deficit of water. But if we use these data, it sends an alert message to the farmer when moisture level increases and decreases, so farmer can decide accordingly. Then pest problem remains a great challenge to improve our yield quantitatively as well as qualitatively. So farmers' hard work is vanished. So with the help of IoT information, he can take advanced decision and act accordingly, whether to spray the chemical or not to spray, whether the insect population is above minimum threshold level or it is below threshold level. So he can decide whether to go for chemical application or whether to go for logging and uprooting such infested plants and destroying them outside the field. Then connected cow means even cows will be connected, or buffaloes or goats will be connected and monitored. Sensors planted in the ears of cattle or the other livestock, it allows the farmers to monitor the cow's health and track their movement, so that when they are left for open grazing, the farmer can take care whether the animals have returned or they haven't returned, how is its health, and how much is its productivity. So on an average, each cow generates about 200 megabyte of information per year. So impact of IoT in irrigation, we have already talked about it, that wirelessly connected sensors control water flow in field and it saves wastage of water and it gets activated, soil gets dry. Otherwise, they remain inactive. Then climate smart agriculture means it helps farmers build resilience to adapt to climate change. Sustainability increases the production of agriculture products. Then it reduces greenhouse emission. IoT solutions enable us to know the real-time weather condition. Sensors are placed inside and outside the fields. They collect data from environment, which is used to choose the right crops which can grow and sustain in particular climate condition. The whole IoT ecosystem is made up of sensors that can detect real-time weather condition like humidity, rainfall, bright sunshine hours, temperature, evaporation, and so on. If any disturbance in weather condition is noticed, then an alert is sent to the farm. Then agricultural drones. The use is increasing day by day. When the kharif crops were infested by locust attack, drones to spray the insecticides, and smart drones have reduced the impact on our environment. The result have been such that there has been a massive reduction and much lower chemical reaching the ground. Means uh, fumes, or we can say the fine droplets ejected out of the ultra low volume spray will have least effect on our environment and pollution. Agricultural drones with different applications. In dryland situation, we can use drones for spraying water over the crop field, and that small amount of water can have miraculous effect on the health of the crop. When the crop is nearing the permanent wilting point, and fine droplets of water can make them rejuvenate and reactivate. The ways drones are being used in agriculture are crop health assessment, irrigation, monitoring. The major benefits of using drones are already told. Then remote sensing means acquisition of data without coming from a distant place, without coming in contact with the object is remote sensing, and geospatial techniques are becoming increasingly important in present context. Use of artificial intelligence, robotics, culture is increasing current times. Then data analysis, you see the estimated amount of data is increasing at an exponential rate. The cloud-based data storage and an end-to-end IoT platform plays an important role in smart agriculture system. In the IoT world, sensors are the primary source of collecting data on a large scale. The data is analyzed and transferred to meaningful information using analytic tools. With the help of IoT devices, one can know the real-time status of the crop by capturing the data from sensors. So these could be different devices, sensors for capturing data with regard to moisture, with regard to light, with regard to other weather parameters, including temperature, humidity, wind velocity, wind direction, dew drops, and air pollution means the actuators and drones and cables. Then how wireless connected sensors can help in plant care means purpose specific sensors are connected to wireless modems. They send periodic environmental data to user over internet, and one analyzes the data and remotely adjusted the plant's environment. So what is the market potential at the moment? We estimate 75 million IoT devices will be shipped for agriculture usage in the year 2020 at a 20% CAGR. These devices are primarily sensors placed in soil to track acidity levels, temperature, variables that help farmers increase crop yield. A large chunk of our agriculture soils are problematic soils. They are suffering from either acidity or alkalinity or sodicity. So information on that problem can be acquired with the help of these sensors. Then smart meters are already a reality, and from 313 million installed in homes worldwide in the year 2013, Navigate Research predicts that number 1 is to 1.1 billion by 2022. So field database, where field significant data are gathered. These the farm implements like tractors can be connected, and with the help of GPS we can place the fertilizer where it is required, and we can skip the spots where it is not required, just to save the amount of fertilizer material as well as cost to the farmers. Then future farms will be like this. They will be small but smart. The survey will be conducted with the help of drones, or there will be a fleet of agri boats, and the farmer will become smart as well as his farm will become smart, and one can monitor everything sitting in his farm office. Then this is just an estimate. Agricultural IoT device shipments globally. It is 75 millions at the moment. Then market estimation. Then the connected tractors. We are talking about connected cars in the cities and in the country. We are talking about connected tractors. Tractor will be there, then smart tractor and smart connected tractors now. So these are different farm implements like tillers, planters, everything will be connected, and it will be acquiring data from the sensors regarding weather, regarding the soil conditions, when to go for farm operations or whether not to go for farm operations. Everything will be The data will be stored in cloud. So the IoT sensors include optical sensors that use light to measure soil properties, measuring different frequencies of light reflection in near infrared, mid infrared, and polarized light spectrums. These sensors can be mounted on vehicles or drones that allow soil reflections and plant color data to be collected and processed there. Soil organic matter and soil moisture can be determined by optical sensors. Soil organic matter is the soul of soil. Now the soil organic carbon content has declined terribly because we are not adding organic matter to the soil, rather we are mining it year after year. So that requires very keen observation, how much we are taking, how much we are adding, and what a prime minister is advocating, that you have to maintain the soil health. So soil health card have been distributed to the farmers, and the first and important data with regard to that is soil organic carbon content. Similarly, moisture is very important aspect. If soil is devoid of moisture, then we cannot go for sowing. If we go for sowing, then it will take a heavy toll to the farmer with regard to the seed and other inputs like fertilizers and labor. So that is a very important aspect, and optical sensors can be used. Then electrochemical sensors. These sensors are mounted on specially designed seats, which help in collecting, processing, and mapping soil chemicals. Electrochemical sensors provide information needed for precise agriculture, soil nutrient level, and pH of the soil. Soil samples are sent to soil testing laboratory, and a series of standard laboratory procedures, means chemical analysis, is done to know the nitrogen content of the soil, the phosphorus content of the soil, potassium, and other secondary elements as well as trace elements of the soil. Some measurements, particularly the determination of pH, is made using ion selective electrodes. These electrodes understand the activity of specific ions such as nitrate, potassium, and hydrogen. Then mechanical sensors are used. These sensors evaluate soil compaction and related to variable levels of condensation. Means use of heavy machinery like tractors or combines or rotavators, they are compacting the soil, which is not good for the health of the crop. So soil remains porous, it must remain friable for quick germination and support the plant growth. So soil compaction has to be monitored. These sensors employ a mechanism that cuts through the soil and document the force measured by the loading strain gauge. Then soil moisture sensors are there. These allow observation regarding soil moisture conditions. These are the type of soil moisture sensor, the design. Then there could be electronic sensors. They are mounted on tractors and other farm equipments. They can be cellular, or they can have communication with satellite system to transmit data immediately to the computer or email to an individual. Airflow sensors, they can be employed for soil air permeability, means physical factors, and measurements can be made at measuring locations or while moving dynamically. The desired output is the pressure required to push a predetermined amount of air into the ground at a specific depth, different type of soil properties including compaction, composition, soil aeration, soil permeability, hydraulic conductivity, soil moisture level can be monitored. Then passive infrared sensors, PIR based motion detector is used to sense movement of people, animal or other objects in the field. Then Arduino, both soil moisture sensor and PI sensors are connected to form Arduino that can perform an action. It will send the data to the database using Ethernet shield, and if emergency, it also sends message to the user by using a device called GSM module. Then the advantages and disadvantages of IoT means they are cost effective methods. They can reduce the cost of production, thereby increasing the income of farmers. They can optimize natural resources like soil, like water. They can be used optimally. Wastage can be checked. They can sustain high yield and they can ensure high quality. But the disadvantage is that calibration for each soil type will be required. Then everything has two phases. One is advantage, the other is limitation. So the challenges in smart agriculture, Dr. Gopi Yadav has vividly described about them. To summarize that, operability of different standards, the learning curve, connectivity in rural areas, making sense from big data in agriculture, non-awareness of varying farm production functions, size of individual management zones, barriers to entry for new farms, lack of scalability and configuration problems, energy depletion risk, challenges for indoor farming, mounting e-wastage, loss of manual movement, means they will spare so many hour labor. The security factors, some risk and privacy is at the threat, and sometimes the benefits are immediately seen. So these are the limitations, or we may say challenges in smart agriculture. We can finally conclude that we can predict soil moisture level and motion of predators like locust and other field the enemies. Then irrigation system can be monitored. Damage caused by predators is reduced. Increase productivity qualitatively as well as quantitatively. Then we can conserve our water resources, and we can finally ensure profit to the farmers. So thank you very much.
Thank you very much, sir. Just we'll see if there is any question, then participants can kindly unmute themselves and they can ask.
Sir, could you explain the contract farming? Because right now it is contract farming is very quite often, and it's been discussing in the society as well. So could you explain, could you highlight some points in contract farming?
Yes, sir. Contract farming means there is an agreement between the company or any organization and the farmer before sowing a crop, where the price of produce is decided in advance. So it is the risk of the company whether the produce will be sold at that rate, whether such the production will be realized or not. So everything the risk of the farmer is minimized. So farmers won't be at the loss. The company, it's the company that will bear the profit or loss. And the our new amendment, the new acts passed by the Union Ministry, out of those three acts, one is related to contract farm.
Yeah, Professor, very
Sir.
happy by listening the lecture. I got a doubt. We can add this Bachelor of Agriculture Technology will be more suitable so that we can combine engineering more with the agriculture. And also, why can't this technology, this particular knowledge will be added in the high school level? Because lot of information is there. So at least we cannot design and all. How things are going on, how to improve the cultivation, how to guard this one, how to safeguard the farmer life, etc. Little bit can be added. No, sir, you're a dean. That's why I'm just telling an idea.
Thank you.
Uh, yeah, that's a Bachelor of Agriculture Technology is more suitable for the present trend. Please give some highlight about it. That's all, Professor.
Yeah, sir, agriculture is the backbone, and it provides livelihood to a major chunk of population. So, some basic knowledge of agriculture must be incorporated in the secondary and
Yeah,
senior
school level.
levels.
Yeah, yeah, yeah.
And sometimes the our new education policy 2020, it has certain points related to this, and every school child will have, or the secondary school level, it will be incorporated.
Yeah, very nice. What about technology, Professor? Agricultural technology, Bachelor of Agriculture Technology. It is
Yeah,
actually I
BTech.
come to know it is in Philippines. They have a course of 4 years. Philippines
Yeah,
already started.
yeah,
In our country, any state, let's say, why can't some proposal by people, high profile people like you, can give no, Professor?
yeah. That can be given to the policymakers.
Yeah, thank you very much, Professor. Thank you.
There is one question, sir, on the chat box. Mr. Krishna Samdani, he wants to know how to reduce the cost of IoT devices since the number of sensors are huge for monitoring each parameters.
It's a very technical, sir. So I can't tell you right now how to reduce
Yes,
the
yes.
cost. But once they are in use, they reducing the cost of farming.
I think by wider deployment of the technologies, the cost can be shared. Means if you deploy some solution to one field, then he has to bear the cost.
Yeah,
Same technology can be over one entire area if we can depute that maybe for some village or some tracts of land, then the cost will be definitely it will be shared by few more, so it will automatically it will come down.
come down.
So I think if anyone has some research orientation in the smart farming, they can ask directly by unmuting themselves.
Sir, only thing is how do we get the data? Because see, we are working in the machine learning model. We are learning in the data analytics part. Because data analytics is what where the data is at rest, and the IoT is that the data is moving. So we are not in the moving side. So let's say if we get the data, and so that we can build a model, whether it is a logistic model or predictive model, and it will help to the society as well, and you to the department per se. So can we get all these data from various sources, or you can provide some sources so that we can access that data, and so that we can enhance our research in that area, agriculture area.
So I think is Mr. Samir Jain. His question is if the university has the data, so is it available for others so that they can use it for their research purposes?
Yeah, it can be shared. That's not an issue, and we can go for MOU sort of things. We can enter into memorandum of understanding with different colleges or universities or the other research institutions, and after entering MOU, we can share the data without any difficulty.
There is one, I think, Node MCU with Arduino. These questions can be kept for some other expert. Maybe now afternoon we'll have Dr. Ankush Vijay. We can keep that question for him. There is one particular question is some funding agencies in smart farming domain. So this will be a great help to everyone. What are the funding agencies?
Yeah. One can formulate project and submit to Ministry of Agriculture, DST, or Department of Electronics and Technology, DOIT. Some
The-
multinationals can also entertain some projects.
Yes, I think partially this was given by Dr. O.P. Yadav sir also when he highlighted some Agnext, then Fasal, those kind of solutions when he told
IMD.
that is startup, so one can contact them also. There is one thing, one Mr. Amit Kadam wants to know, can you highlight the points related to food safety and transportation related things related to smart agriculture?
Yeah, there are certain apps which are available to the farmers that ensures the transportation and similar issues.
There is one another question that please suggest some place in Rajasthan smart farming happen. Is there any that practical implementation? I think government of Rajasthan has taken a lot of steps in this regard also.
Yeah, some institutions are using this irrigation sensors and application of drone. Even in my university, we are planning to buy a drone and demonstrate the use of drone in agriculture. So, in a very short span of time, we will be able to uh, give trainings to farmers and demonstrate it to our students how drones can be helpful uh, in agriculture.
Any other question?
Sir, what are the research journals which we can present our papers in the field of agriculture domain, sir?
Agriculture. This is Indian Journal of Agriculture Science, published by Indian Council of Agriculture Research. Then Precision Farming is another. So you can go for your publication in those journals. They will readily accept because it's altogether a new field.
Okay. Okay.
Uh, any other questions, participants? So, what are the research facilities that has been developed at Sri Karan Narendra College of Agriculture, sir. Can you highlight something? The research initiative
Underway.
by you.
Yeah, it's underway. Means we are in the process of a census, city in ICT, that just to monitor the irrigation water, means how best we can save the
So is it that this project is being implemented on campus or some off campus?
no, sir, on campus. We will test it on campus, then we can take it to farmers field later on.
Right. Uh, One question is on can a farmer bear the cost of IoT system for agriculture? If I think as we have seen, I think in the mobile devices, the earlier mobile devices, they had very less features. I think to early of 2000, it had very less features, and
Yeah,
you can see now how it has improved as the smart solution has come. So you can see the many features of that in a short span of around 10 years, in a decade, the mobile sector has completely changed, and it has changed the life of the common people also. So maybe if we can give some best solution, then a farmer will be readily accepting that. Right.
correct.
I think with this we can end. I think thank you very much, sir, for your insightful talk on the smart farming. Uh, One more question is that is there any sensors available to check the health of plants?
Yeah, for example, infrared thermometer. It takes the temperature of leaves employing RS technique. And there are certain apps also that, for example, Plantix. That app uh, is is like a crop doctor. So the sensors are there. It will send the photograph to cloud, and solution will come within seconds or minutes.
So there are some sensors are there, and then there are some cloud-based solution is also there.
Yeah.
What do you think, sir, most difficult part in the smart where we as a research community where we should concentrate? Like government of India, their motto is to double the farmer income. In a short span that. So
Yeah.
what the yield has to be that efficiency has to be improved. The
Yeah.
crop yield has to be improved,
Yeah.
so that should we concentrate on the insecticides that those parts, or we should concentrate here where what is the that where should we concentrate?
Actually, increasing yield will not ensure more income. Actually, we should reduce the cost of cultivation. We should go towards the efficiency, resource use efficiency. Means our water should be used efficiently. The energy should be saved. The nutrients should be used efficiently. So the resources have to be, or the inputs have to be used very efficiently. We are wasting the seed, sometimes we are wasting the nutrients, we are wasting the water. So that has to be conserved, and resource use efficiency will ensure the the reduce cost, and it will certainly improve the income of the farmers.
Yes, this is quite insightful. That we should reduce the cost of investment, not
Cultivation.
the cultivation.
Yeah.
Cultivation that we should concentrate there. That is the main area that we should focus on. That
Yeah.
will be one great help to all the researcher community, that where we should look particularly, and what is the where the farmer will also be thinking of the same area, that how to reduce the that cost of cultivation, then automatically that your profitability will increase. That It says again, audit in farm. Maybe Shahbaz Sheikh sir, can you ask directly to sir? We are just doing audit in farm, means I could not understand. Maybe you can explain to sir and sir will answer you. Shahbaz sir.
What I could guess that how much we are adding and how much we are getting, means with respect to the monetary terms, with respect to the energy, with respect to the other non-monetary resources, means the efficiency has to be improved.
There is one more interesting question has come from Manisha Narwane ji, that are sensors to check the quality, soil quality. This is very important, sir.
Yeah.
Many a time that crop does not give a good yield if the
Yeah.
soil is not compatible.
Yeah, they are there, but they have not become popular in India. Um, they will sense which type of nutrient is deficient, what nutrient is in excess at a particular spot, and that is the base of precision farming. So I was in Germany some 20 years ago, and they had that type of sensors. So the sensors were mounted on tractors, and tractor used to inject though that particular nutrient which was deficient at a particular spot, otherwise the tractor kept on moving.
I think Manisha ma'am, this how you can use that
Sir, may I
based.
know the sensor names which are used to detect the quality of soil, sir? Any particular sensor names?
Mm, that I can tell you later.
Okay, thanks.
Thank you so much, sir. That there are many questions we have. Any that, but I will tell that we have got a lot of insights from your lectures, sir.
Thank you.
We are very thankful, sir. You have you came to the inauguration ceremony. Also, you were very kind enough, in spite of your busy schedule, and you agreed to give one expert lecture. And I think these case studies, these two expert lectures by OP Yadav sir and yourself, and there are two case studies, and this whole this faculty development program, we thought of integrating the technology part and the application part. Most of the time we have heard of IoT in the smart city applications, but we thought that why don't we go for this IoT, that where a new beginning can be made. And I think this FDP will have some contribution in that, in this direction.
So I must thank the organizers to kindly inviting me and giving me the opportunity to share some of my views with very learned persons, technologists. Thank you.
On behalf of all the participants, I thank you again, sir. I personally thank you. Uh, Thank you, all the participants. We'll meet at 2 p.m. for the next session on the lab of Raspberry Pi. So let us meet at 2 p.m. So again, thank you so much, sir.
Thanks.
Thank you, sir.
Have a great day.
Thank you, sir.